Hello everyone, this is Prabhat and I am here to sort of show you guys or try to make you guys understand how insertion happens in singly linked list. So if you guys are new here, don't know about singly linked list, it is one of the types of linked list uh, in which there are like two basic fields in each node, and node is basically, you can understand, it is uh, node, we call node is just like tag name of a user defined data type. uh, User defined data type, well, we are using C language here to learn singly linked list. So at this point, let's just go make some nodes. I'm going to make you guys understand what is node, um, what is this memory allocated. Sorry about those sounds, because there is this child in my house, and he, when he plays, he like yells quite a bit. So please forgive me for that. Like, I cannot make him like silent. He will start crying then. He's my brother, he will start crying if I try to do something like that. Anyways, let's focus on the topic that we are covering. First of all, let me just draw these, because these are important concepts. uh, I am drawing this because I want you guys to like thoroughly understand how singly linked list, what singly linked lists are, how they work. Here in this one, you guys can check out previous implementation of singly linked list if you don't understand it that much in this video. I am just going to like sort of do this insertion operation in singly linked list, because that is the main focus here. That is what I want to do. I want you guys to know how singly linked list insertion works in singly linked list. And we are talking especially about insertion in the beginning here. Oh, sorry about that. Here, uh, here in the beginning, there are some people shouting. My house is like that. Earlier there like weren't that many children around, so now when there are like children, always keep doing stuff like that. I just hope that I don't like get targeted for like letting children shout and get their voice in this video. I can't hurt them, right? I cannot. Like, they're my little brothers. I cannot even hurt them. I cannot hurt them. I cannot even hurt them is wrong. My English is bad. That's just what it means. Here I am dividing this because this right here is like, there are like two parts in each node. The most basic single linked list will contain at the very least two of these parts in one node. One will contain the data that is input by user, or that is that is assigned at the compile time, or the data that is input by users will be in one field, the data field, and other will be the link field, which will contain the address of the next node, or the address of the next the base address of the next or rather nextly is newly created nodes, new nodes or new space that is allocated where users data is stored. That address is going to be stored in here, so that we can use this field to go to this place, right? So the only reason that we are learning data structure is that is that because we want to learn some techniques which allow us to access and store and access data efficiently, right? That's why we are learning data structure. So let's let me just tell you guys what which node which part is going to point. No, not point, it's just, let's do this arrow sign and write what that part or that field of that particular node, or whichever node it is supposed to do. So at this point here, we will write data, because this field right here is going to contain data. It's not a pointer. Don't confuse it with pointer. I'm just writing so that you guys can understand what it will contain. So now you guys should be able to tell what these are used for. This one will contain the data that is input by user. First of all, when this block of memory is allocated, right? Listen, when you do this dynamic memory allocation or even static memory allocation, when that particular space is allocated, some data is used or input. That is, listen, a little bit of data will be, or whatever data it is, however its amount is, that is input by users. So that data will be stored in this section, and the link to the next node, right? So the link to the next node will be here in this section. So one section is called data, and data section, and another is called next section. Now let's just point what head node is initially. Let's just take this line. Should I? Yeah, I think I should. What is this? This is head node. Nah, let's leave it. Leave it be. We will just write the base address here first. Uh, oh, I've not selected this. Anyways, so let's just do quickly. Let's say that this has 2100. These are not contiguous memory allocation, because linked list, in linked list, wherever the memory in the memory space is there randomly, that some particular memory is like allocated, and its base address is there, right? So basically you need to know that this is different from arrays. The data, like these data will not be in like continuously in continuous look or stuff like that. So at this point, these will not be allocated continuously or contagiously, or whatever you want to call it. uh, these will be at different location, or I'm not saying that they should be at different locations, but they can be like randomly wherever uh, the machine thinks it's fit. So let's say it has 10,000 in it. It's hexadecimal number system, but at this point I am like writing in decimal number system so that you guys can understand it. Let's say this is 230. Let's say this is 480. Now that we have written 480, let's just take this one as 720. So anyway, so these are like the addresses, and now we are going to write some things here related to, like, let's say now the color I'm going to pick a different one. So head is equal to head will head pointer is supposed to store the base address of the first node. What is the base address of the first node? I have taken 2100. I don't take these these are taken by machines, these are picked by machine, but at this point I am just trying to make you guys understand, that's why. So the base address of the first node is going to be stored in head. Now next up, what is the base address of the last node? 720. And last node, we are going to use tail as the reference, tail as the pointer which holds the base address of the last node. So tail is here 720, and there should be some a new node named pointer variable is used to create is used to basically store the address, the base address. In the beginning the base address will be stored in new node, and at that point we will store, and after that we will store it in head, according to if it is the first node, and in temp if it is the second node, and any node that is not head, right? So at this point I understand. If you guys made it this far and you think that this video is worthless, I don't think it is. I'm just going to make you guys understand how things work perfectly, but at this point I know that it will be hard to understand. Linked list is a little bit difficult topic. So let's say some data is used, input by user, that is 2, and the address of the next node. What is the address of the next node? Which is 10,000. 10,000, as you can see, is the address of the next node. So 10,000 will be here, this will be 3, and the address of the next node is 230, so 230 will be here. Here let's say 4, user enters 4, 4 will be stored here, and the address of the next node is 480, so 480 will be stored here. Next up let's say user enters 5, and the address of the next node is 720, so 720 will be stored. We are at the last node, let's say user enters 6, uh, we are here, and this is the last node will store null in its like link field, or the it will not have the base address of the next node, since this is the last node, so null will be there. Null basically means 0, there is nothing in the list. So I hope you guys at the very least understood what I told you guys. This node right here is the head node, this node right here is the tail node, these nodes are in between, right? So, and each node has some data section in it, so that data section will store the base address of the data section will store basically what user enters, and the link part, or this address part, will store the base address of the next node that is created by well, whatever it is, right? It is input by users. Now damn, they are promoting stuff, aren't they? This is annoying. That's why I think I should like make videos in night. Anyways, so this is it. You know these, right? When you're learning data structure, I hope you guys already know why we write stdio and stdlib, right? Because at this point you have to know a language, that's after which you'll be able to learn data structures. Because if you don't know a language, then how will you be able to implement those data structures, these concepts? Well, yeah, if you just want to learn the concept, then you can learn data structures, but I would still recommend you guys to learn a language before. Not completely, but even if you understand these basic things, I think you'll be okay. Anyways, let's continue. So this right here, int main, is basically this is the main function in which we have written the code. In this there is this data type this is data type declaration, or this right here, this is data type declaration, right? We are declaring that this struct node is a data type itself. It is a user defined data type, a data type that we can declare, and this is variable declaration. Like a choice variable is declared which is of integer type. So these are some basic stuff, some basic stuff. Now here, struct node is the data type of value point, which is the value pointer. Sorry about ending. I am apologizing for pretty much everything. uh, so struct node will contain int data. It basically means that data section, there is data section, right? A data section, we are expecting integer data, right? We are expecting integer data from users. They are going to input integers, and we are going to store those in data. And this right here is basically we are declaring a pointer variable, and its return type is this, or rather I would like to this pointer variable, what is it going to store? What is the data type? What is the data type whose address is going to be stored in this pointer variable? The data type whose address will be stored in this variable is struct node, the one that we just declared. So this is the data type whose address will be stored in this node, right? Next up, the struct node head is basically used to store the base address of the first node. In the beginning we are storing null in there, that means there is no first node, right? User has to enter some data so that the first node will be created, but in the beginning there will be nothing in it, right? New node, Again, this is another one of those pointer variables which stores the base address of a struct node type, data type, right? So, and in the beginning that is null too. Similarly, temp is null too. I have not used tail pointer because it's not needed. Or you can write the name pretty much anything, and this right here, this is the concept. Here we are going to like show how uh, like data is like taken as in how memory block of memory is allocated, where we can store data and where we can store the address of the next node, how we can access that thing, and how are we going to do stuff, what is the logic if other node is added, how can we just link them and use them perfectly fine. So that is the concept, this new node stuff, right? You know what's going on, this malloc function or malloc function is used to like create a little bit of memory in there, or rather it doesn't create memory, it like gets that much amount of memory, it reserves that much amount of memory for what, right? Here we are saying size of, right? Here we are passing argument size of what, size of the data type for which we are creating this a little bit of memory. So what are we creating this memory for? We are creating this memory for storing some like data of struct node data type, right? So whatever is the like required amount of size, like let's say 10 kbs or 8 kb is required, so that much amount will be passed uh, as like parameters or arguments, whatever you want to call it, right? And at this point here we write here we typecast. So what is the type, what is the data type of the like size, or rather size, or whatever you want to store, it has to have a data type, right? uh, right, it just has to have a data type, right? So that data type will be passed here. So this is struct node and its base address is being passed to this pointer variable. So there is this, right? So when this line of code runs, a little bit of space will be created, a little bit of space will be created in the memory, and in that space we will be able to input data, and we will be able to contain the address of the next node. So that's what this code is about. So now at this point we have created that much amount of reserved space in the memory, and now we have to access that and put data. So we are telling users that they should enter data, they should enter some data, and here using scanf function we are taking input, right? Where is that input going to be stored? So this new node is a pointer variable, and this will contain the base address of that reserved block of memory, right? Right. So to access the data field, we just write the address, this operator, the address or whatever ampersand operator, and at this point we write this new node, right? This new node pointer name and pointer variable name, and then we write this data is one of the fields. If you remember, this is one of the fields. So at this point an integer data will be like given input from users, from users, and that will be stored in the data section of the node which is being created, and its next field will contain null. That means that since we are creating the first node, there is nothing in the list, right? There is nothing in the list. So I mean, since we are creating we have put some data in there, but there is nothing in there's no other node in the list. There's only one node. So the first node is the last node, and since the first node is last node, it will contain null in the next section. Now since head is equal to null, we have already said that head is equal to null, there is nothing in the null, and the reason we have done it because in the beginning there is no node, right? So at this point head is equal to temp is equal to new node, or rather new node is equal yeah, head is equal to temp is equal to new node, means that new node, the address that was created, right, the address that is created and stored in new node is going to be stored in temp and head too. It will be stored in temp and head to both places. And now that we have done that, we the if condition is true, so obviously we will not go into the else part. We will directly go over there and ask users if they want to continue adding. And if they want to continue adding, right, if they want to continue adding, then this program, this bunch of code will run one more time. And when it runs, right, when it runs, when they want to add another data in the list, right, so some more space will be reserved at certain point and location in the memory, and that base address will be stored in new node. Then again we take input, then again we take input, right. So at this point, let's say data is input by users, there is null in it, and then if user wants to continue adding data, then another block of memory will have a base address. So new node is pointing here, new node is equal to this address, and using this we will be able to write like new node of data is equal to whatever user inputs, and then this will be null. Then again user wants to enter data, so when they want to enter data, this is the place where user basically inputs the data. And then again this next node, next pointer, next field will contain null in it. And then if user wants to enter data one more time, then user will enter this data. This block of memory will be created using malloc function, and it will be stored in new node. And then we will be able to access this part, and then we will be able to input data in this part using new node of data. And new node of next again will contain null in it. And then when this is created, like every time new node is being created, we are updating it. So when this node was created, here we added this variable, this base address, right. And when this node was created and user wanted to add another data, then this address was stored in here. And that's how we keep doing that till the end. And in the end, this next part will contain null. And now this will help us print, right, this will help us print the data. Obviously initially we set temp is equal to head, so temp is pointing to the first node, right. Temp is equal to head, so temp is pointing to 2100. Now we can do temp of data, then we will be able to print this data, right. And then we do temp is equal to temp of next, right, and temp of next is equal to 10,000. So temp is equal to temp 10,000, and then temp is equal to temp is pointing at that point, temp is pointing to here. And now we write temp of data, then we can access this field. And then once we have accessed and printed this using printf function, we go to this section, and in this section we do temp is equal to temp of next, right. Temp is equal to temp of next. So with that means that temp will contain 230 in it now, and that means that temp is pointing over here. And since temp is pointing over here, we can write temp of data and access this field, the data field, and we print it. And then we do temp is equal to temp of next again. So at this point temp is like containing temp is equal to temp of next, and temp is containing the base address, this address. And then that means temp is pointing over here, and continuously it comes here. If we access we access this part, data part, using temp of next. And then we do temp is equal to temp of data, and we do this temp of next to like temp is equal to temp of next to store null in the last next field. And at when temp is equal to null, then this whole program will break, this bunch of code, this while loop will break, and we will have everything printed on our screen. Now this is used, this part is used to reserve some space in the memory. That space is reserved now. At this point that space is reserved. Once that space is reserved and its base address is stored in new node section, right? New node section is new node pointer variable is storing the base address of this newly created node. At that point you take data from user, right? Data from user. And here I have written a lot of useless code here, but what you have to do is first, what you have to do is once you have taken input in new node, what you do is basically listen. Let me just write it here, right? And that will make you guys more clear, right? So now that we have whole link created, we have created new node too, right? So let me just graphically try to make you guys understand, and I think that will be more beneficial to you guys, right? So this right here, and we want it to be the first node. So I think we have to do this. Let's I think do I think and whatever user enters like 99, let's say, and its base address uh, uh, in the beginning the base address is null. I mean the address of the next node is null. Let's say this is 53, the base address of this node. So now we want to add it. This is the concept of insertion at the beginning, right? Insertion at the beginning in the linked list. So single linked list. So at this point we want to do this. No, this is not how we want it to be. Go to the home, pick this thingy, and we get a backy here. Once we are here, do this and do this and once we have done that, we are here, right? This we want it to point over here. How can it point here? Tell me, how can it point here? If we store the base address of this node, this head node, then this will be pointing over here, and this will become the first node. So let's do this eraser thing. I should have done that from the beginning, but that wouldn't have, yeah, that wouldn't have helped you guys understand the concept of how we add stuff. So oh yeah, whatever. So let's write 2100 2100, and at this point this node, when you have the base address of this node, then you will be able to access this node. And this is input by users. This is this is generated by computer. So this memory part is generated by computer, whatever is stored in there, right? So it could be pretty much anything. We have taken input from users. This is the base address of this node, and this base address is stored in here, just like this base address is stored here. So just like you can access this field using this one, right? You can similarly access this node using this field, right? So now in the beginning the head was pointing to this node, and now we have to do head is equal to new node. So if we do head is equal to new node, head will be pointing here. So I don't know, should we save it? Let's leave it as it is, and let's try to run this. I will give you guys this code anyways. Let's just go. Let's see if this program runs. Enter data 1, yes. Do you want to continue? 1 for yes, 0 for no. Let's say 2, yes. 3, yes. 4, yes. 5, no. At this point I don't want to add any more data. Now enter the data that you want to insert, and this is not just insert anywhere. We want to insert data at the beginning, so we want to insert on top of 1. There should be a data that should be above 1. So let's say we want to add 675 before 1. Enter the location where you want to insert that value. Listen, if you write anywhere anything except 1, then you will get an error. Oh, so even if you I think I did some mistake in this program. What is this? Location is equal to 0. Oh, so if you enter 0 only, then you will be able to only then you will be able to sort of write this. So listen, that's why I said that those things were pretty much worthless. That last code that I wrote was useless, right? So I'll write the concept in that. Just watch me. Let's go. We will keep going. We will keep going. Now, now at this point we don't want to. So 1, 2, 3, 4, and 54. So let's. We wanted to add 657. Right? Enter the data that you want to insert. So 635 it was. That's right. Now location 0, and see, before 1 this was input. This was like inserted. So this is basically insertion, right? So if you comment in the like if you comment about it, then I will just send you the code. Like give me what I'll send you the code if you guys need it, but this is basically it. I will write Let me write the concept. So we create new node, right? New node. I should move it this way, this side, so that we can see. And let's change the color to red. Yeah, orange. We will increase its size so that people can see it better this way. Shit. uh, I don't know, man. Let's just do this. Create a box. This is annoying to do in paint. Anyways, let's move forward. uh, Whatever, let's continue. Struct node, right? And pointer sign, or whatever you want to call it, it's called asterisk officially. uh, Size of struct node, you do that. Get back here. At this point you have created new node. I mean, you have created a newly you have a newly created node, and its base address is stored in new node. Right? So now that you have that, you ask users to enter data. Once they enter data, scanf to get the data. I mean, they can only enter data when you write this scanf function. And new node of data. So newly created nodes data section is going to store that value. And new node of the next is equal to null. I always do that, or do this to sort of make sure that there is no like stupid error because of wrongly using memory, or whatever, mistaking something. So at this point we have created the node. Now we want to insert at the beginning. So that new node which is created, this new node, let's say this node has been created, this data has been input. When this function, this like line of code was executed, let's say when this line of code was executed, then at that point this data was input by users. This was the location of this newly created node. Let's say 53 is created in this 53 is the base address of the newly created node and is stored in new node, right? So 53 and this arrow operator and data is basically the like, what should I call it, member of a user defined data address structure. So structures member data. So you can access a member of a user defined data type struct using this arrow operator. So that keep that in mind. Now that this node has been created, we want to make this head node. So in order to make this head node, we have to store the base address of previous node, I mean the first node of the linked list. So initially whatever the head is, right, here head is 2200, right? So we have to do new node of next. Just like we accessed this member, data member of struct, and added data in it, we can use the arrow operator and access the next part, or the part which is named next, the member which is named next. We can access that using an arrow operator and contain or put the base address of the previous head node. And now that 2000 when this code runs, the base address, this base address will be stored over here. Initially it is null. We said the new node of next is equal to null, so initially it was null, but when this line of code ran, then this was input. You can say that this is useless, but I don't want to take chances, and that's why I always initialize the this pointer section, right? Pointer to certain location, I always initialize it with null. So once this value was stored, this line of code ran, this value was stored in here. Now it is containing the base address of the head node, but it itself is not the head node, so we cannot traverse through it. So now what we do is head is equal to new node. That means that now head is not 2000. Now head is not 2000, right? Now head is not 2000. Let's say, let's cut this, uh, whatever you can do to cut it. Once you cut it, uh, let's just write 53, because 53 is the address of this node, and this is the node. Head will store the base address of this first node. Now this node is first node, and its base address will be stored. So this right here, this whole thing right here is the this is the concept of how things work. So I hope you guys got things. If you made it this far, I thank you for watching this. And I let me tell you this, that I have put I am creating this whole data structure section, data structure like playlist, in which like there will be everything related to data structures. I'm still new to YouTube, and I'm not into this teaching. I have not been into this teaching thing. So uh, please bear with me and watch my videos, support the channel, and I will continue to put the good content, uh, right? These are not the topics that most people would like put it on their YouTube channel, because they think that these things are way too advanced to be free. But I am giving you guys this whole playlist and stuff to free for free. And I am not saying that there are not other channels. There are other channels which give you these things even better than that, but I promise that I will have a better channel than them, and I will keep putting even better contents as I move forward. I will even teach you guys how to create applications. This is a promise. I will do that, and please keep supporting me. Thanks very much.